Okay guys, so here's another example for the segment addition postulate. We're still in 1.2. This is just a little extended, more algebra type of example for this postulate. So let's take a look. Nothing we can't handle. Just got to break down the steps a little bit more, but I know you guys can do this. So this one says, in the diagram, JL is 120. So they didn't label that for us, so that's definitely the first thing I want to do. Label that whole thing, that whole segment is 120. What are JK and KL? Okay, I want to figure out what's the length of JK and what's the length of KL. Right now, it's in terms of X. Okay, I'm going to have to do some algebra here. The first thing we want to do is set up that segment addition postulate. We want to write it out by saying the two parts that add together to equal the whole. The two segments that add together to give me the one big segment. So that's where I get JK plus KL equals JL, the entire thing. And then what we're going to do is substitute in these expressions for the segments. So JK, I'm not going to keep writing JK, right? I'm going to write 4x minus plus 6. Okay, 4x plus 6 in for JK. And then 7x plus 15 for KL equals JL is 120. From there, we just have to simplify this, guys, and that comes down to combining like terms, okay? And if we need to write some steps in here, there you can see everything, you definitely want to write that combining like terms. So what that means is I'm going to look here at these x's, right? Take a look. I have 4x and 7x plus 7x. So we can combine those. 4x plus 7x gives me 11x. And then I'm also going to combine my numbers. 6 plus 15. 6 plus 15 gives me 21. Okay, remembering the like terms, guys. The like terms, so I combine the terms with x's, and then I combine the terms just without x's, plain numbers. So that's how I'm left with here. 11x plus 21 equals 120. From there, what we want to do is I want to focus on getting this x alone. Okay, getting that x alone means I need to move this 21 to the other side first. So I'm going to do the opposite of addition, which is subtraction. Subtract 21 from both sides, which is going to leave me with that 11x on one side equals 120 minus 21 gives me 99. From there, how do I get rid of that 11? So what operation is happening between the 11 and the x? Multiplication, right? So what's the opposite of multiplication? Division. So I need to divide both sides by 11, and I get x equals 9. Okay, that's good algebra in there. Probably algebra 1, algebra 2 might have been a while, so feel free to jot down some questions, and then you're going to ask them during our next synchronous live Zoom session. Okay, so that is how I solve for x. But remember, it doesn't ask me for what's x. It wants me to find jk, this whole length of jk. So what I have to do is I have to look at jk and just plug in, substitute in this 9 for the x. So notice down here it says 4x plus 6, but now I know what x is, right? I stick 9 in for x. 4 times 9 gives me 36, plus the 6 gives me 42. And I have to do the same thing for KL. KL is 7x plus 15. I know what x is now, so I'm going to substitute 9 in for x. Anytime we substitute, we want to put in parentheses. Now I'll do 7 times 9 gives me 63, plus that 15 still is 78. And those are my answers, guys. Those are my final answers. 42 is JK and 78 is KL. Okay? Remember to jot down any questions, and I can't wait to answer them during the synchronous session. We're going to do a practice of this. The last example for this section, guys, and then we'll be finished this section, is talking about this new topic of congruence. Okay, so, and we're going to hit this vocab word all year long. Congruent means there are segments that have the same length. Okay, we've been talking about length this entire section. And what this means, there's a new symbol that we have to talk about. Okay, congruent uses this symbol right here. It's the equal sign, but there's a squiggly line on top. Oh, it didn't squiggle. It's but with a squiggly line on top. Let me get a different color. The equal sign and then a squiggly line on top. You can see it right here. So how we use this term congruent? We use this term congruent to say that segments have the same length. Okay, so I would say segment AB is congruent to segment CD. That's how I would read this. Okay, we use the word congruent to talk about geometric figures and like whether that's a line, shapes, whatever. We use the equal sign to talk about the lengths themselves. So here I would read this as the length of AB equals the length of CD. Lengths, the equal sign we use for numeric expressions. Okay, if I'm talking about the length as a numeric expression, that's when we use the equal sign. On a visual, so on a diagram, how do I represent congruence? See that little tick mark right there. As soon as we see a tick mark, okay, we know, oh, AB is congruent to CD. Okay, that tick mark represents congruence. So how we're going to use this vocab word in examples, we're going to take a look at this, these problems down here. So it says, find AB. Remember, doesn't tell me length, distance. Whenever I see two points written next to each other, we need to find the length. So I'm going to jot down that formula, BD equals the absolute value, remember, x2 minus x1. I go ahead and put x1 and x2 on my number line, right? Like it's a visual, it helps us. So B is going to be my x1 and D is going to be my x2. And then I plug those two numbers, substitute those numbers in for the variable. x2 is 2 minus x1 is negative 4. Okay, when I subtract a negative, it turns into a positive. So 2 minus negative 4 really becomes 2 plus 4, which gives me 6. The absolute value of 6 is 6. Okay, so I found the length of BD, perfect. This question says, name a point that is on ray CA. Okay, name a point that is on ray CA. I know it's a ray because I have this bar with one arrow. So CA is right here, and it helps to highlight. Right here's CA. Start at the end point and go to the other point. Name a point that's on there. Yeah, point B. Perfect, right? If you follow that highlight, point B is on that highlight. Another reason highlighters are really helpful. So now it says, is line segment AC congruent to line segment BD? And how do I know this? So remember, if something's congruent, they have the same length. So isn't that what I have to find here? What's the length of AC and what's the length of BD? And if they're the same, I know they're congruent. Make sense? So, find the length of AC. So here's another way we can find lengths. You guys are going to laugh because it's easy. Find the lengths. We use the number line. Go to A, 1, 2, 3, 4, 5, 6. So my length of AC is 6. And my length of BD is 6. We already did that one. So are line segment AC congruent to line segment BD? Yes, because they have the same length. Okay, so you would say yes, because they have the same, ran out of room, the same length. Okay, The next question, why is a statement such as length of AC congruent to the length of BD incorrect? So notice how I read that. No bar means that that is a length, right? If there is a bar, it means I'm talking about the segments. Remember up here, the only things that we can say are equal to each other are numeric expressions. When there's no bar, I can't say things are congruent, okay? So associate bars with congruence, no bars with equal, okay? So that's why that statement is incorrect. And then my last question here, what is the coordinate of point D? Remember what a coordinate is. It's that number on the number line that matches up with the point. So my coordinate of point D is 2. Okay? Awesome job, guys. That's all we're doing in section 1.2, measuring and constructing segments. Okay? Great job, guys.